VLSos here. This is a video lesson on the sum and difference properties of logarithms. Here I'm going to show you a general log property that always works as long as you follow the pattern. Log base b of anything x plus log base b of anything y is equal to log base b of the product x times y. This is the sum of two logs. And if you have anything that follows this pattern, you can convert it into a single log with the same base, and it will be the log base b of the product of the two arguments or the two things that you're taking the log of on the left side. For example, log base 2 of 3x plus log base 2 of 1/3 is equal to 5. An equation that we want to solve for x. X is part of the argument of this log. We want to undo everything to get x by itself. But taking the log or the power base 2 of both sides is complicated by the fact that we have one of the sides as something as complicated as the sum of two logs. We can convert the left side into a single log by using this property. I can see that I have the sum of two logarithmic expressions, both with the same base. So I can combine them into a single log with the same base by taking the product of 3x and 1/3. The right side remains 5. Now I'm ready to undo the log base 2 with a power base 2. When I do, the log base 2 and the power base 2 cancel out, leaving the 3 times x times 1/3, which can be simplified to just x. On the right side, 2 to the 5th can be evaluated as 2, 4, 8, 16, 32. The 5th power of 2 is 32, and we've solved for x by using this property. There's another property, very similar. Log base b of x minus log base b of y can be simplified into a single log with the same base of a fraction whose numerator is the argument of the first log and whose denominator is the argument of the second. Let's use this property of logarithms in an example. Log base 4 of x squared minus 4 minus log base 4 of x plus 2 is equal to 3. This is a rather sophisticated equation. It is the difference of two logarithmic expressions. The log bases are the same. So I can convert the left side of this equation into an expression as a single log using this property. When I do, it will be a log of the same base 4 of a quotient formed by the arguments of these two logs, where the numerator is the argument of the first log and the denominator is the argument of the second. And this is still equal to 3. Now I can undo this log base 4 by power base 4ing both sides. Cancels out. Here I can see what remains will be a difference of squares in the numerator. So I'm going to take that step immediately and see that x squared minus 4 can be factored into x plus 2 times x minus 2, and it's still being divided by x plus 2. This is equal to 4 to the third, or 4 times 4 is 16, and then times 4 one more time is 64. The difference of squares pattern created a like factor that could be canceled out, leaving x minus 2 on the left, and we can see that if we add 2 to both sides, we'll get x by itself. Solving this equation was made much easier by using this log property in the first step. Let's have one more example. Log base 3 of x plus log base 5 of y is equal to 10. This is the sum of two logs, but we can't use this log property because this log property requires that the log bases are the same. And in this case, the log base is 3 and 5, not the same. So we cannot simplify this with the property.